Good morning. We'd like to welcome you to this planter clinic here at Bruna Brothers Implement. We'd like to also thank you for your business. Over the last 74 years, Bruna Brothers Implement has grown to be a partner with you, and we appreciate you trusting us to be that partner. It's important for our business and yours that we work together in these kind of activities to make you as successful as possible. We've got some folks here that we'd like to introduce here real quickly before we get started. We've got a few of our planter mechanics from Bruna Implement. First of all, we've got Paul Brocksterman here on our panel. We've got Scott Miller on our panel. From Case IH, we've got Scott Sweezy, and he's the Manager of Field Service Operations for the area, for the territory. Presenting today, we have Eli Peterson, and he's a planter specialist for the region. He'll be putting on the majority of this activity today. And we have Brad Kaiser, who is the Territory Sales Manager for Case IH. We'd like to thank you for your business. On behalf of both Bruna Implement and Case IH, you're a key and important part of what we do. Without you, we're not here. So again, thank you very much for joining us today. And I'm going to go ahead and turn it over to Eli Peterson. He's going to bring you through this, and hope you enjoy and learn something from it. Thank you.
Very good. Thank you, Martin. Morning, everybody. Today we're going to go through some planter maintenance and different setup and wear items for the 2000 series and the 1200 series planter. So as I mess up, these guys are here to correct me. But basically, we're going to start on the back side of the tractor and talk about the marriage between the tractor and the planter first step. So whenever that marriage happens, there's a couple things we want to keep in mind. A, make sure that your hydraulic lines and your electrical routing is clean and clear. If you have a 2-point hitch, make sure that as you guys go over the terraces, go through corners, waterways, whatnot, make sure that those hydraulic components, those electrical components are not going to hairpin, catch, or as you raise or lower the toolbar, anything's going to get removed from the back of the tractor. There's some components back there that need to stay attached, obviously, so we want to make sure that that connection is as healthy as we can keep it, so we don't have any wear over season or malfunctions when it comes to the back of the unit. As we hook those hydraulics up, there's a couple things to consider. The hydraulic lines are color-coded, so their caps that are on the end of the hydraulic lines, there is color codes to those caps. Green goes with green, red goes with red, etc. Red is generally going to be your frame function, so make sure that that remote is somewhere close where you like it inside the tractor. So if it's on number 1, if it's on number 5, 6, whatever your last remote is, something easy to get to. The remainder of the remotes are generally left in what we consider a motor mode or a constant on. And there's some settings in the tractor that we can make to increase that, motor mode being one of those. But as the remainder of the hydraulics come on, your bulk fill system that we'll talk about in a little bit, your vacuum controls. On the 2000 series planter, we have an alternator and an air compressor that's also ran by hydraulics. If you have liquid, all of those take more hydraulic demand. We want to make sure that as we hook the systems up, we do a decent job of making sure that the systems are connected in a way that when all systems are on, then we don't have a starving of hydraulic oil at the tractor. So coming to the end of your field and it's slow to raise. So trying to avoid those types of situations. So after the marriage of everything up front, we can kind of pan towards the back, and we'll dive into some of the systems that we have. We'll start with the, we'll go to the back and we'll start with the row unit and talk about the ground engaging components, some of the maintenance perspectives and the wear items on it, and then we'll come back and talk about the systems and its settings. So on the back of the 2000 series bar, there you can see, for those of you that have a 1200 series planter, the ground engaging components really haven't changed. You have the trailing, or the
What's that?
front mounted pivot point, so our reduced inner diameter gauge wheels are pulled through the field. We have behind the gauge wheel a set of offset disc openers, so our disc openers do not touch at the very point at which we cut into the soil. We have an offset leading edge, so that way we can cut through residue. The gap of that furrow is going to be a little narrower than most of the competition due to that, and allow us a better cutting edge and less disturbance as we get into creating that furrow. On the 2000 series planter, the discs themselves, we have a left disc and a right disc as we are offset, but on the 2000 series planter, those discs are now a single part number. On a 1200 series planter, whether it's a 12X5 or a 12.5 planter,
He's going to try to get the old one to work.
we have a leading disc part number, we have a trailing disc
That
part
would be
number.
better.
And then based on the
Old link is whatever.
side of the planter that you're on, the left side of the planter bar is going to have a leading edge, and then the right side of the planter bar is going to have a leading edge. So on a 12 row, first 6 on the left side, left disc will be leading. The right 6, so 7 through 12, is then going to have left disc leading on the left side, right disc leading on the right side for your split. So one thing that we do want to check as we come through and create the furrow is making sure that this system is in check. Ground engaging components, again, disc, the offset disc openers, and then inside of the offset disc openers, we're going to have a couple of components. We'll dissect at the table here in a little bit, but directly behind the offset disc openers is a furrow firming point, or a furrow forming point, depending on which model you have. The purpose is the same, and as we go through, we have a set of disc scrapers here. Again, this is just to clear mud or debris away from the disc. In heavy clay type conditions, a lot of mud, very sticky. If you have issues with buildup of mud or residue on the inside of the disc, we do have the option to put scrapers on the inside of that disc. So you can have a set of 4 scrapers in total if need be. We can source those through parts. So as we come through and we create the furrow with the offset opening discs, we use the reduced inner diameter gauge wheels. The reduced inner diameter is to allow that soil to actually build up or move up and not be in a compacted zone. So when we create that trench and we push that soil open, we can actually build a berm, so to say, or create that furrow, so that way we don't have a compacted, rigid edge that we have to take down later. So after we drop the seed, create the furrow, smooth it, drop the seed, as we move back, we go to our 2-stage closing system. The 2-stage closing system, we have a couple of different options, but again, in comparison to the 1250s, 1240s, the 55s, 45s, etc., this system here is going to serve the same agronomic purpose. We have our we have our dual disc offset furrow closers. So we're actually going to close the furrow that we just created. These discs are concave and have increased in a diameter. They're now up to 9-inch diameter. But the purpose of this here is to actually take that furrow that is open and close it from the ground up. So we're actually going to pinch the bottom of that trench and pull the trench back closed as we pass. So instead of using a V-pinch style system, we're going to use this 2-stage to actually close the trench a little more gradually. We're going to take a little compaction out of there, and we're going to try to keep we're going to plant to our depth. We'll talk to our depth settings here in a bit, but the depth that we plant to hopefully has some moisture at the bottom of it, if our depth setting is correct. The idea is to drop the seed in the best furrow that we can, and then as we come by and close that trench, we surround that seed with the soil that's at that depth, instead of trying to break down that sidewall with V-pinch wheels or anything else and forcing soil on dry soil or topsoil on top of that seed. So trying to surround that seed with the best environment that we can. Ideally, we're at that proper moisture level if our depth is set correct, and we can keep that seed to soil contact what we need by then creating a good seed density, or excuse me, a good soil density after we run it over with our pneumatic press wheel. So there's a couple of adjustments on these that we can talk to while we're here. This system, as we have it set up, there is a air cylinder or a pneumatic cylinder inside for our closing system. If you do not have an air cylinder, you have a spring option. There's a light and a heavy spring. B, C, and D are going to be the settings that we can then look for to increase spring tension as we go further down the alphabet. The objective or the goal that we're really looking for is to make sure that that trench is closed complete. So as far as the settings and adjustments, there is a stop that we have. We have two stops. One's generally for corn, one's generally for beans. As far as a depth perspective, plant a little deeper in corn, we can keep it on the bottom pin. Plant mainly beans on the shallow side, we can go and raise the pin up, but that's going to be our depth stop. So if we need to add pressure, or if we're having issues closing because we have a tough no-till field or a lot of residue or anything like that, we can really push the system here to make sure that these closing discs are as far down as they can be, but not too far to actually dig into the furrow that we just created. So more or less a stop, so that way if we need to increase pressure, we can, but we know that we can only push so far, and we can keep the cylinder and the furrow intact. Going back a little bit further, the press wheel that we have in the back, there's a couple of different adjustments, as well as a spring. In order to get this to close properly, we do have a couple of different options for springs. Generally they're set on number 2. This will give you a little more tension. Again, the goal of the pneumatic press wheel is to roll over that trench and create good seed to soil contact. So if you were to come back afterwards, after you run the planter through the field for a test pass, if you have a leaf blower, if you have a paintbrush, or anything that's light to move soil, if you were to come back over the top of that trench and you brush it off, blow it off, however it is, and you see a little V, then we need to make some adjustments here and possibly think about increasing tension here. But that is a good indicator to look over the top of our press wheel indentions to find out if that furrow is closed and closed all the way. For those of you that do have a V-pinch style, if you have opted to go that route, use the same test and make sure that that furrow is closed, and that seed, if you were to dig, that seed has good contact all the way around. So if you were to dig and you look at the bottom of the trench and there's an air pocket where the seed is, that's where we would need to look at increasing the pressure that we have here, or increasing the pressure here. From a factory adjustment though, we'll talk about generic settings, I would say that in your standard till, conventional tillage, if you want to call it that, B or C position would be fine. If you go to you're more of a no-till, spring position D is probably where you want to be. And then from an air cylinder adjustment, if we start somewhere 18 to 20 pounds, or excuse me, 18 to 20 psi in the cylinder, that'll give us a decent start and keep us in that range between heavy and light. So, Scott, Paul, anything to add when it comes to the closing system and the objectives of the two-stage and planting the seed? The other thing that we want to keep an eye on, especially as we get into setting the planters, we want to make sure that all of these adjustments and all of these components are doing their job at the depth that we set. Paul, what's a good depth?
For corn, 1.5 inches.
1.5 inches? Why 1.5 inches?
That's where we normally plant.
Right. There's no really rhyme or reason to what depth needs to be at each, at the start of the season, at the end of the season, field to field. What's the goal of planting to 1.5 inches?
To get down to the moisture, so you can. Right.
Exactly.
So
we want to get down to the moisture level and understand where that moisture is. So if we can do all of this and we are not, let's just say we're set and we want to plant to that 1.5 inches. We went out with our pocket knife, we dug and felt moisture, we know where it's at, and we set all of our row units up for 1.5 inches. If our row unit is not calibrated, or we don't really understand what 1.5 inches is on our adjustment, what's that going to do as we go through the field? Going to have some sort of variance or error. So as we go through the inspection year to year, we want to make sure that our depth setting is something that we can monitor or watch row to row as season goes on, primarily season to season. We'll talk a little bit on the 1250 here in a second, but on the 2000 series row unit, one of the large changes is that instead of having the corkscrew type handle on the back of the row unit, we actually have a T-handle. This T-handle here is spring loaded. There's a backbone on the back side with some teeth or some stair steps, and it has an alphanumeric gauge. The T-handle is beveled, and that's going to be an indicator. As we make our adjustments on the planter, there is a difference between in this case, we'll just look at B2 or B1. If we look at B1 bevels back, or bevels facing the closing system, versus B1 bevels facing the meter, we have an 1/8 of an inch adjustment that we just changed at the furrow. So that simple pivot we can raise or lower that depth by an 1/8 of an inch. So we can go from essentially 0 to 3 3/4 inch at 1/8 of an inch intervals. Again, the purpose of that is so that way, we can get to depth. But the other thing on the 2000 series, you won't find this much on any other OEM, but there is a published depth gauge to that position. We'll talk about the adjustments on the older style 1200s here in a minute, but we didn't publish a depth prior to this row unit. So we have the ability to calibrate this setting and understand what setting on the planter actually relates to what depth we're actually planting the seed in the furrow. So that way, as systems wear, this one being an outside row unit, if we hang out, we're along the fence line, we're along the tree line, we're always running up against, running through sticks, whatever else. This one's probably going to wear a little bit different than, say, row 13. That's always in tilled soil. It's always in good conditions. It's going to be different than, say, row 8 that's directly behind the tractor. It's always in a compacted area due to the vehicle pulling it. So as we go through season and go into the next, we have the ability to spot check and understand what each row unit is planting at. We can make that adjustment to keep them all consistent. While we're here, we'll do some quick maintenance points. As we looked at this, I did not point out any grease zerks. That's something that's going to stay common really between the two units. We still don't advertise. We don't have any grease zerks on the unit itself. A couple things that we need to keep in mind through season. We want to oil this pin here. Ideally, if we were to oil this pin just with an aerosol lubricant, so WD-40, PB Blaster, what have you. At the end of the day, if we can oil this pin and let that oil soak overnight, bigger concern is over season. We want to make sure that the oil on the pin doesn't cause any issues seizing to the linkage here. So keep that joint lubed. And then as we go further, that's really it. If we were to get a greaser or a grease gun out, we don't have anything to do here. So we talked about creating the furrow. We talked about what components we have in there to make the furrow and what the objectives of the two-stage closing system need to be. When it comes to wear components, again, ground engaging is going to be an item that we're going to have to look into season over season. Again, your opening discs are a single part number. We want to watch if we have more than, Scott, correct me if I'm wrong here, but if we're over 3/4 of an inch wear on our overall diameter, we need to look at replacing these guys. And then if we are a inch wear on the closing system, we would need to look at replacing closing discs. As far as settings, Scott pointed out, we'll look at the level here in a second. The other thing that we want to watch as we tow this unit through the field is we want to make sure that your row unit is parallel to the ground. And I understand everybody has hills and terraces, and it's not always a perfect flat square field. But when we level the unit in the field, our parallel linkage, again, our row unit is always going to be parallel to the frame. So as we hook up to the tractor and we set the hitch to an operating position, we want to make sure that the frame is level or parallel to the ground so we can allow the gauge wheels all the way back to the closing system to be at the same position, and you're not pulling them through the field and your closing system riding up, putting more pressure at your opening system riding up, putting more pressure on your closing system, or vice versa, trailing with your your opening system forced into the ground and your closing system not having the opportunity to actually close the trench as needed. Very good. So keep an eye on that. Make sure that, again, the parallel linkage will move the row unit parallel to the frame, make sure that the frame itself is adjusted so that way it's parallel to the ground. One other system that we would need to look at this point in time, we talked about planting to depth. A couple of options that we have, making sure that the depth stays. If we plant at that 1.25 inches, we plant at 1.75 inches, we plant at 3 inches, it doesn't matter. Whatever our depth setting is, that we look at making sure that the row unit is at the depth. And we would do that by looking at feedback in the cab. So on a 2000 series planter, you have the ability to run a hydraulic downforce, or you have the option to run a pneumatic downforce or airbags. If you have hydraulic downforce, you have active feedback on every individual row. If you have airbags on the 2000 series, you have a feedback per section. And the goal of that system is to put pressure on the row unit, or in a delta force scenario, if we don't need pressure, actually lift the row unit to make sure that we have the gauge wheels at the depth that they need to be. So the wobble bracket that we have up front here, as we pull forward, we're going to put strain on a linkage inside of the row unit frame. That linkage is going to have a strain gauge on it, and it's going to be connected to your T-handle adjustment. So that's how we can make our adjustment. And then whenever we hit depth, our gauge wheel is all the way up, pulling on this linkage, putting strain on this gauge. As we have a reading on this strain gauge, then we have force on our gauge wheel. If we do not have a reading on the strain gauge, we do not have force on our gauge wheel, that means that our gauge wheel is somewhere in this area, meaning that we're not planting to our full depth. So we'll look at the settings in the cab here after a while, but what we would want to look at as far as an adjustment is we want to make sure that the gauge wheel has a force on it at all times. From a row units perspective, we've talked about the two-stage opening system, our offset disc openers, the reduced center diameter gauge wheel, pushing the soil offset to create that furrow. We have the furrow forming point up front to flatten that trench out, and then we'll drop the seat on top of that. We'll then close this, close the trench in more of a zip type form. We're going to close the trench and pinch it back together, surrounding the moist soil around the seed. After the trench is closed, we will then create the right seed to soil density or correct soil density with the right seed to soil contact, eliminating any of those large air pockets and closing that trench or stitching it for good. Scott, did you have anything to?
Yeah, there were a couple things I wanted to point out based on some observations I've had in the field. The first one is aftermarket. We're going to talk a little bit about aftermarket components that can affect the row unit. The first and one of the most obvious ones would be residue managers. Lots of different aftermarket residue managers. One thing, the most common ones anymore are the floating residue managers. One thing it's very important to do is to make sure that you've got your lower stops set correctly. We just want to get that material out of the way to make a nice seed bed, nice bare soil so we can get the soil temperature up to get that seed out of the ground. So make sure that when you're setting your residue managers that you're just moving a little bit of material, the residue out of the way and not tilling your soil with those residue managers. That can make the row unit work a lot harder, make it pull a lot harder with your tractor. and create some possible more wear points. The other thing from a wear point stand is if you have a unit with delta force, we have seen a little bit of accelerated wear in the bushings on the parallel links on the row units. If you're running delta force plus running higher speeds through no-till conditions, harder soil conditions, faster speeds, faster creates more wear in the system because it does pull harder. So one thing that you want to do before planting season is check all 8 bushings on the row unit. You don't have to take them apart. Generally, you can just kind of wiggle the row unit and look for any gap spacing or wear in that area. The bushings are replaceable. I have seen a few bushings in the past where the wear got so bad it started to egg out into the parallel link. So we want to catch that wear prior to it wearing into the parallel link. The other aftermarket solution that guys will put on is fertilizer. A lot of guys are running at least one product on the planter, whether you've got an in-furrow fertilizer system or if you're trailing it out back of the packer wheel. The main thing to think about when we're putting it in the furrow is make sure that wherever that outlet is for the fertilizer, it is above the bottom of the seed trench. I've been in the field several times and we have row space or spacing issues, and if that fertilizer tube is sticking down too far, it can actually hook and drag seed. So you want to make sure that that's well up out of the way. The other thing is when you're putting a high volume of fertilizer on, you always want to try to put that out back of the seed trench, because lots of fertilizer, build up, gets sticky. This wheel will start building up. We do have 2 positions, so if you've got fields with rocks where you're getting rocks in this area here, you can move that packer wheel back to give it more space for those rocks to naturally work themselves out. But just make sure that when you're running your fertilizer out back, that tube is pointing away from this packer wheel, because we don't want to get any buildup here, because then the tread pattern, the center forming line that puts that crease right above that seed cannot do its job.
Very good. Thank you, Scott. Now that we've talked about the row unit and majority of its adjustments and what we're trying to make it do, we'll start to dissect it a little bit. We'll talk about now actually getting the seed metered and actually getting the seed dropped down to the tube for the accurate placement that we're after. So on the 2000 series planter, there is a new seed meter design. All units, all configurations for a 2000 series planter are going to be electric drive. So that's why we have a controller on each individual row. Basically all of the monitoring and adjustments on the row, whether it's delta force, whether it's the seed meter, the seed tube, if you have any in-furrow liquid with individual row control shutoffs, all of that is going to come out of this controller here called the single row module, or the SRM. You'll see it's flashing at a 1 hertz rate. If all rows are flashing at a 1 hertz rate across the board, then everything is synchronized and correct. If there is not a row flashing at that 1 hertz rate, there's likely a warning inside the cab on the display with that row number on it. So we'll go into the seed placement. We'll dissect the meter at this point in time. To remove the seed meter, we'll have to take the bulk fill off if you have bulk fill. There's a vacuum hose on the other side that we'll have to take off. There's a collar that will slide out, and then we'll pull off the meter. There's an electrical harness that we'll have to take apart, single connection electrical harness for the V-drive meter, and it simply slides off like this. We'll dissect that here in a second. if we need to remove the seed tube in any manner, here's your connection for the seed tube. Simply a 3-pin. We have a couple of different options for seed tube and seed monitoring. I'll take the pin loose. I'll pinch the top of the seed tube, and as I pinch that, no component, no tool removal. Notice we have a Dickey-John sensor. This is the standard Dickey-John optical sensor. So there's a couple of different LEDs that are inside of here with a receiver. As seed passes through, the LEDs will determine that something was blocked, and it will, if it's about the size of the seed, it will count that, and that's how your seed meter will report in the cab. Now, Scott, I don't know, as far as conditions go, we do have an aftermarket option for customers that are planting in really dusty conditions. A lot of, maybe it's debris, whether it's dust, whatever it is. If we have an erratic reading on the seed tubes, on multiple seed tubes across the board, we have the opportunity to put a wave vision seed sensor in. And the wave vision seed sensor is going to basically use microwaves to look at the mass of the object floating through. It's not going to go directly off of the interruption of a light ray. So it's a little more robust when we get into unideal conditions with a lot of dust, a lot of debris, and anything floating back inside that seed tube.
Yeah, and that's one of the drawbacks of a vacuum planter, is that it does kind of have a tendency to pull some dust back up the seed tube. Like a lot of guys will make that comment that going one direction, I've got good sensing of my seed, but going the other direction, if you've got a tailwind coming up the planter, that can make that worse. The other possibility is guys planting, especially with a 30-inch planter, planting high-rate soybeans, where you've got basically a steady stream of beans going across that sensor. The optical sensor cannot keep up with that, especially when we get to a rate where there's just a steady stream with no gaps in between the beans. So that's the places where you may want to look at going with a wave vision sensor. Generally, most of the time in corn, the optical sensor at those rates performs very well, unless you get into a very high dust or a lot of debris in the field or a windy day.
Very good. So as long as we can detect the seed and determine seed placement coming through the tube, there's a lot of feedback that this sensor can give us in troubleshooting, and we'll talk about that later on. But at this point in time, we've covered pretty well every component on the meter, and we'll actually dive into, every component on the row. We'll actually start to dissect the meter itself and look at wear items and exchange parts from crop types. So earlier you watched me remove the housing for the 2000 series row unit. We're going to navigate to the 1200 series row unit, and we're going to point out a few differences, a few maintenance points that we need to look at and things to consider, and then we'll dissect this meter as well. So this here is a 1250, or excuse me. Yeah, this one here is a 1250. It is a 16 row, so similar in configuration to our 2150. However, our drives on this unit are going to be hydraulic. I'll get out of the way so you guys can see. Our drives on this unit are going to be hydraulic. We do have a sensor to determine rotation. Basically, the command or the population that we set in the cab or on the display will turn the individual chains on the hex shaft. Will chain drive to the meter, and then on this particular unit, we'll look at the AccuRow air clutches to then disengage the row as it goes into a previously planted area or crosses a boundary line. Notice this one obviously has a few more moving components, a few more points of maintenance that we need to look at, whether it's connections at the hex shaft, making sure that the couplers and the dog drives and everything are meshing as the planter unfolds. Our chains are not kinked or pinched, and we have good contact all the way around each drive sprocket. And then same thing going back to the row, making sure that the dog drive going to the meter is actually catching to spin that unit over. Seed delivery and the meter operation is going to be on the same concept, as we're going to deliver on a bulk fill or a mini hopper in some cases. And then we're going to use vacuum to suck the seed to the meter to get that rotation so we can actually singulate that seed and place it into our seed tube. We do have pneumatic airbags for a downforce on this unit. The 1200 series planters do not have any direct feedback as far as ground contact goes. So we talked a little bit about the load cell on the 2000 series planter. We do not have a sensor on this unit that will sense any sort of ground position or ground engagement. We have to somewhat rely on our instincts and our preset settings to make sure that this unit is planting in the ground itself and to the depth that we desire. So a couple of different concepts from an operation perspective. We do have a corkscrew type adjustment. We have a numeric gauge. They're going to be numbered as just general values across the board. If we look at close row to row, you'll actually see a variance in these values, and that is expected. In other words, row unit, the one we're going to dissect here is 13. Row unit 13 compared to row unit 16. Again, as to each row down the road, it's going to wear at different rates as we put it into different conditions. So this gauge here, we might say that, well, number 10 is always 1 3/4 or 2 inches. That might be true for this row because that's what we measured, but we really need to measure each row and make sure that our depth setting is accurate to the gauge wheel to bottom of opener disc clearance. So when we measure depth, we'll actually, in the field, we'll actually measure to the bottom of the press wheel to the seed as it sits in the furrow. So this depth will actually be our true depth. We won't measure seed to where the row unit was riding. We'll measure from the seed directly up to where the press wheel was sitting. So again, not every unit's going to be the same. There will be a slight variance in there. What variance depends on age of planter, acres, conditions across the board, but let's just say if you were planting 2 inches depth, would you be satisfied with a couple of units planting 2 1/4, and would you be afraid of a couple of units planting shallow at 1 3/4? If that's concerning at that point, then we need to look a little bit deeper at each individual row and make sure that this setting here with this gauge, we actually set that to measure the bottom of the gauge wheel to the bottom of the furrow to get a good indicator of where that unit's actually going to be sitting. We can compare that row to row and then get a good set. As we go into the field, we can then measure from the bottom of the wheel or the top of the furrow to the seed that's then placed hopefully at your desired depth beneath it. Again, the 2000 series planner will be able to zero that out, so that way we understand row to row, we can start with a baseline 0 and then set our adjustment from there. That pretty well points out the large differences from the row unit itself. The meter is going to be a little different as far as design goes. So we'll take this apart and we'll swap to the table and look at dissecting these at the same time. All right. As we get set up here, if we see, Scott, what row does that belong to?
13.
13? Am I going to put it in row unit number 12?
No,
Why not?
because it's worn into the cover plate on that meter.
That's right. So as we look into the meter itself, the way that this is designed, the cover plate and the meter are actually going to create a seal. So if you can see on the camera, I'll try to hold this still, you can see where those wear marks are on that vacuum. So here's our vacuum entrance here, and you can see where that meter has worn against these surfaces. So we're actually relying on the meter disc as well as the meter housing to create the vacuum seal, so that way as the disc rotates and it picks seed up, it can actually hold that seed or pull that vacuum and hold that seed against that disc, so that it can then be singulated and dropped. It'll be singulated, and then we'll cut vacuum off and drop the seed down going into our seed tube. So there are some things that we want to look at when we look at the 1200 series meter, and one of which is disc flatness. So making sure that if we were to set this on the table on a flat surface, we don't have any warpage. We want to make sure that this does not warp or twist in any way. Storage, we would recommend that the storage on this, we actually disassemble, take the meter out, and then store all of your discs labeled for the meter that labeled for the row that they sit on. We store those discs in a hopefully I'll call it a humidity controlled environment, but something that doesn't have a high humidity swing. So stack them together, throw it in the shop, throw it in an office, whatever it may be, and then making sure that the meter housing here is reassembled and then kept with that specific meter. If we were to take the meter off and we look at the meter's flatness, we want to make sure that we don't have any warpage at the meter itself. So same thing, kind of inspect the meter, make sure that the meter's not twisted or warped over time, and then same for the disc. We'll keep these two components together throughout their life cycle, and then at that point in time, when we need to replace one, we'll replace both. How do I know when to replace these items? There are a couple of wear indicators. So on the housing, you'll look and we'll see a couple of different wear points, these divots on the triangles on the wear surface. We'll keep an eye on that, as well as the disc that mates to that surface. We'll actually have a couple of different grooves that we'll keep an eye on. As the disc wears, we'll make sure that that wear doesn't surpass that groove. It's kind of like reading the tread on your tire. Get past that groove, it's time to look into replacing it. So that'll be the meter and the disc for the 1200 series. A couple other things that we're going to want to look at is the agitator wheel. This will just slide off. We want to make sure that I believe there's 8, all 8 of those agitators are in contact. This one here you can somewhat see. It's getting a little thin on the edge. We had something catch it on the back. So we'll want to keep an eye on that going into the next season, make sure that all of these are still in contact. The point of this is to make sure that our seed that will be delivered from our bulk fill sitting at the bottom of the meter can get agitated. So if we have any sort of seed treatment or we have any lubrication that we put in with our seed, we don't cause balling or plugging or bridging. We can keep that agitated so that way the meter and the vacuum can pick the seed up. We do have a couple of different types of discs with different holes. More so for your singulate, or excuse me, more so for the population that you're going to be planting. Scott, will we change discs all the time if we're going from corn to beans?
Yes,
All the time.
yes.
So we'll have a bean disc, we'll have a corn disc.
Corn disc, and most customers have 2 bean plates.
2 bean plates, very good. So again, make sure that the plates stay with the meters. And then as we go from crop to crop, after we inspect the meters, or after we inspect the discs and install the discs, make sure that our singulators are set correctly. The singulator will be able to adjust here. You can see an indicator. We'll be able to move with our thumb or our finger, and we'll be able to twist our singulators so that way they cover up more or less of the hole that the seed is sucked to. We'll start to look at replacing these whenever we have some sort of deformity, is first thing to look at. But second thing, you'll be able to see this ring. There's a little lip between the edge and the main surface. As those rings begin to wear, or as you don't see those rings anymore, that means that surface has wore off, and we would look at replacing this housing, and we would take these bolts out here and put a new singulator in. As you notice on this meter here, we do have a handful of brushes towards the bottom. This brush here looks like it probably should be replaced. As you can see, the bristles are no longer formed. There's a bunch of debris. We should probably make sure that that debris is clean season to season. So as we look at new brushes, this is what they should look like. We should have 2 sets. The discs should sit inside. There's a short line of bristles and then a tall line of bristles. And we'll snap that out and put the new one in. But we want to make sure that when we store these, we take the discs out, we can let these brushes, we can clean these out, and they won't take a shape, so that way we're set and ready to go for next year. Scott, anything that, either Scott, you guys have anything to add from a meter's perspective?
One thing that is a major difference between the 2000 series and the 1200 series is the seed disc. With our 1200 series planters, the hydraulic drives are more critical for seed disc selection. So depending on your varieties of corn, your populations of corn, same as soybeans. Soybeans can vary from year to year, as you know, on seed size. But one thing to remember with the hydraulic drive, it does have its range where it runs optimally. So if you go to the field, you select the incorrect seed disc, that can require you to run a faster or a slower hydraulic drive rate, which could put it, especially when you go too slow, that hydraulic drive has a tendency to be a little jerky and can affect your seed placement. The other thing is when you go to replace a seed disc, you will see a seed disc that has the bevel on the back side. So the bevel is in there. You want to run the bean, or the seed should be running on more of the sharp edge. The bevel should be away from the seed. That's for if we get, especially we get a lot of dirty seed. If you're planting milo or such, that's usually a fairly dirty seed that's got holes and stuff in it. So if we get something in there, it has more of a tendency to come on out the backside and help to be self-cleaning. So that's one thing to remember as you're changing varieties, changing seed rates to maintain that optimum RPM on your hydraulic drive. And then I think Eli showed you, but when you're checking your meters, you want to make sure that your singulators, that the spools are good and they're not getting flat spots on them and they're lubricated. That's a good opportunity to take a bottle of graphite and just dump down in there and kind of work those into that area to help keep those turning. One thing is, I know a lot of the historic Case IH planter operators that are used to running 100% graphite in our planters. When we go to the 2000 series, we recommend a graphite talc mix. A lot of that is, everybody's been out to a planter and you touch the planter and there's a little bit of shock. We can get a lot of static electricity buildup with 100% talc. With the electronic drives on the new seed meters, we want to try to eliminate as much as that static electricity as possible to try to eliminate any feedback or damage that could cause back through discharging through a motor or a sensor.
Very good. So yeah, after we've checked and looked at the maintenance inside of the disc itself, again, from storage season to season, we'll make sure that the discs stay out of the meter. The meter can actually, I'll call it breathe, but we can clean the brushes, make sure the brushes return to their original position, and then we can put the housing back and not have to worry about any disc warpage. Anything else on the 1200 series meter? All right. While we're on the 1200 series, we'll talk a little bit more about detailed components. The furrow forming point that we have and the seed shoe basically are going to sit at the bottom of the trench, assembled like this. The seed tube is then going to sit directly behind in the seed shoe. The seed tube will sit right here and the seed will drop at the bottom. We'll make sure that the furrow does not cave in on top of it. The seed will be placed as it comes out the back, and then we'll close the system with those with those two-stage with that two-stage closing system. We'll zip that trench back together and then run it over with the V-press. Or excuse me, we will run it over with the pneumatic press wheel, creating the right seed to soil contact. If we have a V-press system, if you take that option on the 2000 series planter, there's a couple of different things we have to change on the back of the row unit to make that happen. But ground engaging components, again, we'll touch the bottom of that furrow, we'll take that W out. So we want to make sure that the edge on the furrow forming point, we still have that edge. And then as we go essentially further back, if we replace the furrow forming point, it's recommended to replace the seed shoe as well. So if we replace one, we replace the other. As we go to the 2000 series row unit, here's what the new components look like. So not quite a direct swap. They are a little bit different in design. You'll notice that this one's a little more beveled, if you will, if I can hold it right. Notice that the bottom's not exactly a V, it's a little wider. We're going to widen that trench out. We're going to form it so that way if there's, depending on the seed that you plant, the diameter, the size, whatnot, we will be able to touch the bottom of that furrow and not worry about any soil, any air gap underneath that seed. So this will sit in front. There will be 2 screws that will hold these two together. Go in from the back of the seed shoe, and you'll notice that on the edges of the seed shoe, they are not protected by the forming point. So as this seed shoe begins to wear and this edge comes off, we'll then look at replacing these 2 items. So again, that's at the bottom of the trench, creating that furrow. Adjustments wise, if we go up to the top of the meter, or to the top of the row unit, we'll get to the V-set meter. Drastically different than the ASM meter, or the advanced seed meter. This one here again is a precision planting source component. So they're V-set and V-drive. This is that patented technology. The meter housing and both on the mini hopper as well as the meter housing itself was co-designed between us and Precision Planting. To take the meter off, there's a tube in the back, or a clip in the back. You'll be able to flip the clip up. The meter will slide out, and it'll fold away. Now, this is a little smaller than the original ASM, diameter-wise. You'll see the V-drive motor here, and we'll have 2 clips that we can pull and latch over. This will fold apart. And we'll have a singulator. This singulator is, well, both of these are for corn. No difference. I had this component out. But the singulator is non-adjustable. It'll be non-adjustable on all crops. So we won't have the adjustment that we had on the ASM. Had it on too long. Yeah, so we're non-adjustable, and as far as replacement goes, you'll notice that we're color-coded. So we're color-coded between the disc, the ejector wheel now, and the singulator. So V-drive motor that you see here, V-drive motor is going to go through a set of basically reductions. The main drive gear will actually drive the outside ring. And then the meter, then we'll see, we can pop off with guess that's what happens when we just leave the key on. So as we disassemble, you'll see you'll have a disc. The disc will be sprayed in graphite. You will have a vacuum seal. And then you will have an ejector wheel as well. The ejector wheel is going to ride on the back side of the disc and mate together. And as hopefully you can see, the ejector wheel will then sit and knock the seed off of the disc if there's any sort of pinch or wedge, as it then pushes it down into the seed tube for that proper spacing. So from a seasonal changeover, we'll look at going from corn to possibly soybeans. The items that you're going to replace will be the disc, the ejector wheel, and the singulator. Make sure that your cogs are engaged. Make sure that your ejector wheel is pushing any debris outside of the hole. Close your pin, and we can fold it back together. There we go. And then a single spring on both sides, and this device, or our meter, is assembled and ready to go for season. Now, again, like I said, we'll change it. Crop types, we'll have one corn, we'll call them crop kits. So the crop kits will consist of these three components. You'll have ejector wheel, meter, and singulator. If you were to look at a soybean crop kit, you will see that we changed colors. Went to brown. We'll have a soybean singulator, soybean disc, and a soybean ejector, soybean disc, and a soybean singulator. One other thing to note, inside the crop kit, there is a very small spring, and that very small spring will actually hold the singulator wheel up against the disc. So it's just a simple, you'll pinch, put those into place, and make sure that that spring is pushing up against that singulator. While we're in here, again, seasonal maintenance, make sure that the seal is fresh, it's not rolled over, it's not dry rotted, it's not cracked. The brushes on the other side are not full of debris. Seasonal maintenance, we will recommend that the singulator, the ejector wheel, and the disc are removed from the meter housing, and the meter housing is assembled with no parts inside. The brushes and the seal will stay over season, not too big of a deal. But the other advantage that we have with the VSET and V-Drive meter is that this device here, when it comes to a row-by-row wear component, tolerances, and with the seals that we have, it's not as critical to keep disc 1 in meter 1 to match with singulator, to match with ejector wheel. We can be a little more lenient in that perspective. Storage-wise, we would still recommend that, again, everything comes out. We put it in a toolbox, tackle box, whatever it may be. It's still good practice to label and put everything back in the same spot, but it's not critical as it was with the 1200 series row unit that we had. So, Scott, anything on the VSET and V-Drive?
You might mention the one that's actually on the singulator.
Yes, very good. The little spring that Scott's referring to is, pop the singulator out here, press and pull. There's a spring keeper, and then there is a spring that will actually hold the singulator down so it can ride on top of the disc like such. So it'll actually push down to make sure that we have the singulator in the right spot, and this does not rise up or out in any manner.
That's just one that's commonly missing if it's not kept track of.
Yep. So as we do season inspection, crop changeovers, whatever, what have you, we'll make sure that the spring that just sits inside these two little keepers, make sure that it's there. Going through storage and changeovers and whatnot, we hit it in the wrong way. It is fairly easy to remove. Again, on the VSET and V-Drive system, you notice we disassembled everything without tools. So there's no need for any tools or any kits in season. So again, we'll fold her back together. And in we go. We're set and ready to go. Scott, can you think of anything else on the meter that we would want to check? Anything else on the row unit that we would need to verify before season starts?
I think you covered most of it pretty well.
Okay. From an options perspective, if we were to look at a couple other piece parts that we have on the table, we'll focus on what I have on the towel here. This is the Delta Force system. The Delta Force system, again, will report to the single row modular, that row unit SRM. We have a solenoid on our Delta Force cylinder, and then this is a load cell. In this case, this could be a retrofit on a 1200 series planter. If you wanted to upgrade or update your the ability for feedback on the planter itself, and you have a 1200 series unit, you can update to Delta Force, you can update to a VSET V-Drive. That opportunity is out there to do so if need be. From a feedback perspective, again, probably the most critical part is making sure that we have the row unit at the proper depth. And airbags is good. It's going to give us a little more control over springs. But really what we would, in order to understand what we're truly doing, this sensor here is what's going to allow us to get that feedback in the cab to make sure that we have the ground contact we need the row units planting to the depth that we set. So if that pretty well covers it on the row unit, then we'll switch over and we'll talk about the toolbar. We'll go back to the 2000 series here. We'll talk about a couple of additional systems that we have on the toolbar itself, and then we'll dive into display setup. So couple of systems that we have new on the 2000 series unit. You'll notice a rather large air compressor on the toolbar. So in the back here, we will run all of our pneumatic systems. If you have pneumatic downforce, if you have pneumatic cleaning system, or a pneumatic closing system. All of that will come from this air compressor here. Service side, we haven't talked a whole lot about daily service points because frankly, there are none. One of the items to check on a regular basis is making sure that we have drained this on a 10-hour interval. So daily recommendation, make sure that we don't have any moisture buildup inside the air tank. Keep the systems from building moisture inside. So check that on a daily, as there's a site here for the oil compressor, on the oil for the air compressor. We'll make sure that oil's sitting and that's no water's gotten in it, and we can still see oil on our site gauge. Again, just visual check. Outside of the standard, you'll see, again, hydraulic lines and air lines routed all over. As we do our standard walk around, make sure that there's no buildup of dust, there's no leakage around any fittings, and everything's clean. Particularly when we go to adding liquid to our system, making sure that the liquid fittings, the hoses, and all of our routing is clean and not dry rotted, not cracked, not leaking, so that our liquid system here is actually delivering liquid to each individual row. There's no plugs inside the line, and then B, if there's any maintenance issues, that we get that addressed right away, so that way we can eliminate the possibility of any corrosion or anything like that, especially with the chemical that we have inside. So system-wise, again, we have an air compressor on the 2000 series, liquid you might have on a 1200. Operations, we'll get into a little bit, but similarities are pretty well the same between the two. And then the we have an alternator in the back corner now. With all of our electric drive motors on each row, we now have an alternator, and inside, right behind the cover, we have a Group 31 battery. So seasonal maintenance, what we would want to look at over time, making sure that that battery is stored correctly, and then it's charged and can hold the charge throughout season. If the alternator does not turn on for either the battery not being there or the battery not being able to hold a charge due to maintenance or what have you, if there is not anything in that system, the planter will not plant. We will not pull power from the tractor. We will create power on the planter with the alternator. We will feed the battery on the planter, and we will plant with the power that we created on the toolbar. So, all said and done, as you continue to add all the systems up, just for some quick numbers. Alternator is going to take about 4 gallons a minute. Your bulk fill and your vacuum are going to take roughly 9 gallons a minute. If you have a 24 row, you have two vac fans, single bulk fill. So as your planter configurations vary, look on your bar, look at how many motors you have, and you can kind of add that up as you, again, connect to the tractor at the start of the season. Make sure that you're not pulling all your oil out of a single circuit on the tractor if you have a twin flow pump or a setup of that sort. So making sure that you don't starve the tractor because we plugged the bulk fill and the vacuum onto the same motor supplied from the tractor. I guess as we go back further on the bar, we'll talk about bulk fill, we'll talk about vacuum, and then we'll get into actual settings. So going to the back, your bulk fill, you'll have a distribution box at the very bottom. You will have the ability to remove or clean this out season to season, year over year. If there is crop, that is, if you have seed inside the bulk fill tank and we need to get inside here. We didn't look at it before season started, and we had some friends that built a nest in there. We can always remove this black cap. There is a bar that we can then insert and shut off seed flow. We can drop the bottom two compartments, and we can then take out whatever nest has been built in there, that part of that seed bag that's holding flow, any restrictions that we have in the distribution box itself. We can block that seed off, do what we need to do here, close everything up, remove that, so we don't have to empty all the seed out at once if we need to get into that section. So something that we need to look at season to season. Additionally, if you do have a bulk fill system and you are on your first season with it, crop has not gone into that bulk fill tank yet, whenever you start, after you have loaded the tank with seed, take 2 extra cups of graphite for each bin. Do me a favor and drop a 1/4 cup in each corner, or a 1/2 cup in each corner, so that way graphite can coat the edges of that bin. It'll help seed flow over season. Help any bridging or buildup that we might have as if that bulk fill bin is not lubed yet. Settings wise, as far as recommended bulk fill goes, depending on your crop type, depending on your population, depending on your speed, there will be a variance. We do want to look at a base setting. Generally bulk fill, Scott, you guys normally run around that 3,000 range, 28, 32? 33? Yep. So run the bulk fill. A good check that we can do at the start of season when seed goes into the bulk fill, we can look at the mini hopper on each row, and on the mini hopper, take the cover off. As seed gets delivered to the coupler, if you look at the bottom of the hose, if seed is built up to cover the top of that hose, this here, if seed has built up to cover the bottom of it, you have adequate seed flow. So if you turn your bulk fill on and you want to check and see, make sure distribution has happened across the back of the toolbar, we can remove that cap and then make sure that you have seed in each of those mini hoppers. Let that be for now. Scott, any other items that we need to look at from a bulk fill perspective?
No, it's the same system from the 21 or the 1255.
Yep.
I don't believe I've had to work on it since it came out. Works
Yep.
like a champ.
Not a whole lot of change. Not a whole lot of change on that. Vacuum will be about the same concept. We're not going to change a whole lot from the vacuum side of things as far as the operations go. The design and the routing of the vacuum hoses is different. If you look at the back of the toolbar, across the toolbar here, you notice you don't see any of those big bulk tubes, no extra fittings going to each row. That's because inside of your mainframe bar, we're carrying your vacuum. So here's from section to section, here's a feed. So again, depending on how large your planter is, you may have more than one. But from a settings perspective, you will notice that vacuum is a lot easier to obtain with the 2000 series than, say, a 1250. So the hydraulic system has been redefined and is working pretty well. And we were able to create more vacuum with less on the 2000 series. We'll talk about each of the systems in the display as, I guess, the last thing I want to mention as far as maintenance on the toolbar itself. About every 50 hours, so give it 2-3 days, depending on how you operate. Going to each of the pivot points, whether it's you have a pivot fold, whether you have a front fold, the wing cylinders raise and lower for the wheels. We want to lube those every 50 hours. But outside of that, we really yes, thank you, and your markers every 50 hours. That pretty well covers it from a operation component perspective. We'll dive into the display here. If we can get Scott to turn the power on for us. All right, so we'll walk through setup. We'll go through a couple of run screens. We have the key on, we don't have any systems on, so again, in order for the system to plant or in order for us to actually do any sort of work, all hydraulics need to be supplied before we turn anything on. So this is a main run screen for us. If we were to go back and for season setup, for any of those of you that are new to the 2000 series planner or not familiar with the operations of the Pro 700, we can go directly, again, this will be your home screen here. You can hit back and we can go into Wizards. And because we're inside, we don't have GPS. Yes. Okay. Whenever we start, if we go into the Wizards, you can start at full setup. Full setup is going to walk you through everything that you need to operate the planner on a seasonal basis. Once we get through the full setup, we can then change our operation day to day, whether it's crop type, whether it's field, what have you. We can do that through the daily operation. So we'll walk through the full setup and get everything prepped for season start, and then we'll go into the daily operation and go field to field. So full setup, it'll start by asking us a series of questions. Basically, this is just a questionnaire or a guide of what are you going to be using on your planter, what do you intend to use on your operation, so the display knows what settings it needs to prompt you so you can set them for season start. So make sure that your vehicle selection is correct. So it's going to say toolbox display setup screen. If I go back, toolbox, I go to display, current vehicle. If this was connected directly to a tractor, if I had a 280 Magnum, 250 Magnum, and current vehicle should say large tractor. So you would say large tractor, and then you can go to vehicle here, and you can make sure that your vehicle serial number will display, and all of the tractor settings are detected by the display for operation. So I left that screen, I go back into Wizards, I'm back where I left off. I don't have to go through this setup again. I can go ahead and hit next. Verify the total number of row units is correct number of rows. I'll go ahead and say that there's 16 of us. Do you intend to use GPS in your operation for mapping? Yes. Intend to use section control or Acuro clutch control? I'll keep that as a yes. Again, from the electric drives, that comes factory fit. We can control each row on off individually with the Pro 700. So use that. Prescriptions for product rate control. If there are a need for any prescriptions after I load my grower farm field, I can assign a prescription to a product and I can run that route. We can hit yes in this case for those of you that might be running prescriptions. Container function is going to be a generic counter. There's no sensors to the containers, so and it will basically monitor any system that you have on the planter. So if you have bulk fill and you have scales, we don't have to use this. You can look at your scales and understand what weight you have left in the tank. If you have a liquid tank and you can't see the liquid inside of it and you want a good idea of when to stop and check, you can use the container and basically it will count, tell it the size of your container, tell it the liquid that you have in the container and the rate you're applying it, and it will basically do the math in the background of what area have you covered, what rate did you apply, how much do I have left. So there's not a direct correlation or direct sensor, so if I don't tell it the right information, it's not going to count for me. But if I give it the correct information, it'll give me a warning at let's just say 10% if that's what I set it at. So 10% volume left, I'll get a warning saying, hey, I'm low, I need to look at replacing or refilling my liquid. Intend to do split planter mapping. This would be in a case of I have two bulk tanks. I have seed variety A planting on the left. I have seed variety B planting on the right, and I want to track that. There are a handful of situations where that is handy, but for the most part, I would say that most everybody will do a single rate seed across the entire bar. So we'll leave that as no and we'll hit next. Factory supply liquid fertilizer. In this case, yes, that's how our planter is equipped. If you have an aftermarket system that is, or maybe you are running an OEM tank and valve, but you have an aftermarket controller, that would be a no. In this case, we are controlling the liquid pump, we're controlling the valve through the Pro 700 and the planter software. So we're going to say yes, and we're going to run liquid that way. So we're going to go through, it's going to have us create an operator, select our units. It's going to say select your crop type. We'll start off with corn. Get your grower farm and field set up. Make sure that your GPS location is correct. Again, tractor type detection and everything from our verification. All of that data imports correctly. It's not going to allow us to change some of these if we have a preset vehicle, but basically we need to understand where that GPS receiver is sitting so that way as the system does its math, it knows how far back the planter is. It knows where row number 1, row number 2, all the way to row number 16. It knows where that is sitting behind the tractor. So that way, as we crest into overlap or as we cover over a boundary, it knows when to turn those individual rows on and off. Same thing for variable rate or changing rates. So make sure that all of our measurements are set correctly. Since we're in the shop, we won't get GPS. If you have a correction source that is higher than WAS, planting's probably the time to use it. WAS will give you a general operation accuracy somewhere pass to pass, we'll call it 3 to 4 feet in a 15-minute time frame. You get outside of that 15-minute time frame, and our system's going to get a little less precise as the days go on. So one other thing, when we talk about correction type, WAS, if you're looking to do some sort of controlled traffic, strip till, those types of operations, WAS probably isn't going to be the best option for that type of operation. If you simply want to guidance, just give me a straight AB, get me to the end of the field and back, or guide my tractor for me around the terrace, shouldn't have a problem with WAS. Implement, it will detect that we do have a 2150 16 row. It's going to break out our rows into sections. We won't have to mess with that too much. Oops. Row width, if you have a 1245, a 1240, or a 2140 planter, your row width has the possibility to be 15 inches. So if you have a 15-inch splitter planter, this is measuring the iron on the toolbar. This is not setting which row units we're using. This is setting the iron on the toolbar. So in this case, we are set up for 30 inches. Bar distance will measure from the fixed axle. So for those of you having mechanical front wheel assist, we are going to measure from the rear axle to the application point of the row. So we're going to measure straight back, and we're going to measure to the end of our row, or we're going to drop the seed. That's going to be our bar distance. If this distance is not measured and set correctly, we're going to have issues with seed placement and control going in and out of headlands, pre-applied areas, and boundaries. So make sure that that measurement is adjusted correctly. Outer clutch group size, this is going to ask us, do we want to stick rows, in this case for a 16 row, 1 and 2, and then 15 and 16 together. So that means if row 16 shuts off, row 15 shuts off. If row 15 shuts off, row 16 shuts off, etc. on both sides. This is to get around the lower accuracy correction source. So if you're running WAS and you're having issues through the field where your row closest to your previous pass is shutting off at random, likely we have some sort of GPS drift over time. That GPS will drift a little bit. It will think we're in a different location by a couple inches. If we get into a situation to where that drift is enough to think that row 16 is into the previously applied area, I can group these together and I can give myself some insurance to say that I'm going to have to get GPS drift beyond 60 inches before those two shut off. So if you're going through the field, going through passes, the outside rows flicker on and off, this is the setting that we would want to look at to keep those on through the infield pass. This is more or less configuration, making sure that we have the right implement. Do we have the right items configured? Yes and no. In this case, we have liquid fert, we have markers, bulk fill, and we do not have active granular chemical. Bulk fill lights, downforce control is hydraulic, it's not pneumatic, and our wing downforce control. Majority of the time this option is going to be yes. If you order a planter configured with delta force, the hydraulic downforce, it is mandatory that you have wing downforce control. We'll talk a little bit about the settings, but the purpose of this is to get the weight from the center section where the bulk seed tanks are sitting, get the weight from the center section onto the wing frames. So we want to make sure that when the row units require more downforce, our delta force system is pushing that trying to get that row unit into the ground to depth, if the toolbar is not enough weight, that wing downforce is giving it a little more mass to push against, so that way we can actually achieve the depth that we're after. Implement cleaner and closer. Yes and yes. We have cleaners, we have closers. It's going to ask this. There should have been a little additional piece. This is asking for the pneumatic control or in-cab control of cleaning and closing. So if you have the clean sweep cleaners, or if you install a Martin system and you use the OEM air tank, you still have manual control over those if we set up that for the cleaner. Same thing for the closer. If you have pneumatic control or you tee into those valves for any other application, you can add yes and have manual control from the cab. We're set up for corn, so we're going to go ahead and select a work condition. If you do not have a work condition already pre-populated, it will auto-generate you one. And that's fine, but basically, no, it would have been better to have a battery inside, but the work condition that we're after is going to basically store all of our presets. Your corn disc has a certain number of cells to it. Your bulk fill and your vacuum will be at will run in a certain operation from corn than it will to beans. So we'll look at pre-saving all of those settings against this work condition. And then we'll be able to have all of those, when we switch from corn to beans, we change the one value, and then we don't have to reset all of our settings. So our seed cal value, 27 seeds cells per disc. We'll make sure, for now, we'll actually go back and do not make that as loud. You guys turn the battery charger up? Yeah. Okay. So we'll go back into the wizard. Again, we'll pick up where we left off. Because we have liquid in this case, it's going to ask us to calibrate. We need to look at the liquid cal value that's printed on the label of the flow meter. And then the liquid product delay, we can pre-tune, but this is basically going to be the point at which you command on to the point at which liquid falls out of the tube or wherever you have that exit at. So at systems on, systems to pressure, you hit start. How long does it take for that valve to turn on before you have liquid actually coming out at the exit that you're desiring? We want to make sure that these two values are the same, or these two values are set. Liquid cal is going to make sure that we track the right application. And then our product delay is going to then make sure that our section on, off, and our start, stop is accurate to the speed that we're traveling. Set your bulk fill rate. If our standard rate is 32, 35, $3,400 for corn. Vacuum rate, we can adjust 18, 20, 19, whatever it is, depending on your crop type. Again, all of these values are going to save to that work condition. So if I need to change from corn to beans, I'll have these settings predefined for beans. I don't have to go through and change each individual one again every time I change crop types. If you have any overlap, if you're doing, if you want to plant row 1 back on top of row 1, do like a half rate type. Or if you want to Generally, it's more for seed crops, planting for seed the next year, male, female varieties. Those will generally stay at 0. Downforce, we're going to have a preset setting for downforce. We'll look into a couple of things that we can watch. Again, we're really after making sure that the row unit itself is at depth. And that reading comes back as ground contact. If I have ground contact, I'm at depth. If I don't have ground contact, that row unit is not planting to the depth I had predetermined. So, depending on the speed, crop conditions, conventional tillage, no tillage, you can go heavier or lower. But the value that we're going to look at again is that ground contact. We'll look at that after setup. Work condition, Scott briefed us about the cleaners in front of the planter. If we're talking about cleaners, whether it's a clean sweep, whether it's another aftermarket setup and we're using the in-cab control, again, making sure that those stops are in place so we don't dig. It's not a tillage tool. We're just cleaning the debris out from the front. A lot of times we'll actually see the cleaner mode in float or lift. So we just want enough to keep that furrow clean. We don't want to go in there and dig. So we can tell it to float or lift, or in heavy conditions where we actually need to scratch that surface and we need to get residue out of the way, we can go to down. But again, these are the default settings that everything's going to start at. So I got lift set at 8 psi for the cleaners, and I got a closer control for about 22 psi to close that trench. Use planter speed. If you have a speed source on your planter configured for any reason, we're not using the tractor for that speed source, we can hit yes. But if you're using the tractor for your speed source, we can say no and be fine. We'll have to use, on your frame cal, we'll have to set a couple of different heights. Your stop plant, your start plant, and then your limited raise and unfold height. So stop plant and start plant, this legend is in the order at which the bars should read on the graph. So your start plant should be above your stop plant. Your planting depth should be below both values. The objective of start plant is you want seed essentially to start planting as soon as the discs create any sort of furrow. So as we're going into, we're driving along, we're in field and we set the planter down, we want the meter to turn on essentially as soon as the discs engage the ground. And then we can close a trench. When we stop planting, we want the stop height to be closer to the furrow depth. So that way as I raise it up, I don't dribble seed on top of the ground. I want to still be able to get seed in a trench and it closed. That way I'm not leaving any trenches open or dribbling seed on top of a scratched surface. Limited raise will then be at what point does the planter lift up all the way for in-field use. So we're going to set a point at which it will lift so I can turn around on my headlands, turn around on my end rows. That limited raise, really as long as the row units are out of the ground, give it a couple inches. You don't want to have to go too high if you don't want to. If you have items that you're driving over, terraces, hills, whatever else, and you feel like you need a little extra, then we can raise it up a little more. And then unfold height is going to be the actual full height of the toolbar as it's unfolded, so that way we can actually fold our wings out and get everything ready for field operation. If you do full frame, you will walk through all of these calibrations. Follow the directions up top, and it'll basically explain everything that we just walked through. We're going to cancel this and we're going to go, there we go. Frame cal, liquid cal, again, liquid cal is going to be fine-tuning the flow meter, making sure what went through the flow meter is actually what was measured on the ground. So implement work condition. If you change liquids, viscosities change drastically. You have one field and you're planting something that pours like water, and you got another field and you got some stuff that's a little more like molasses. You're going to have a different rate that comes through. We want to make sure that those cal values are set based on that work condition. So in this case, if we had two different types of liquids that were drastically different, I would, corn with liquid and say what liquid I had in each case. And then when I change those liquids on the planter, I can change my work condition and not have to recalibrate. Here's where we're going to assign seed to layers. So here's a little visual on the right-hand side. Based on the work condition and the controls that I have. In this case, we're going to have 3 different controls. We'll have a liquid, a seed left, and a seed right. We said that we're not going to use a split planter map. So we're going to treat seed as one layer. So left and right are tied together. Both bulk tanks are feeding all rows with the same product. So we'll assign product and we'll make sure that our crop type is correct to that product. Hit next, we'll set the default app rate based on that crop type. It'll walk us through and tell us a minimum and a maximum, and then if we need to change it in the display as we're running, right, our default's going to start at 26,000 seeds an acre. If I need to go down, I'll change at 1,000 seeds an acre every time I hit down. If I need to raise, I'll change it 1,000 seeds an acre every time I hit raise. Change that rate manually in the cab. If I have a prescription or a manual rate set, this minimum and maximum that I have predefined is all the more that that planter is going to plant for that crop type. If I need to plant more than 29,000 seeds an acre, I have to tell the planter it's okay to plant more than 29,000 seeds. So I can come in here and say, I might have an instance where I might plant 30, and I might get concerned in some cases, so I'll leave my max at a 32. At that point in time, I can run anything from 24 to 32,000 and have no limitations. If the prescription calls for 34, if I want to command 34, it's not going to happen. I have to come in here and change it. Putting liquid down, again, make sure that the product is there. If you don't have products, you can edit name or create a new one. Add your attributes to it so we can track it. Again, we're going to tell layer number 2, this liquid here in red, we're going to tell layer 2 that you're going to put down 1034. So in the map, whenever you click on that layer or whenever you print it after the end of the season, it's going to say that you applied 1034, and then that controller that's controlling that layer will then tell it how much you applied and where you applied how much. We'll have a default application rate. Again, your minimum and maximum will set the same way that we did for seed. If we have additional products, if we have more than one crop type, or excuse me, more than one variety that we want to plant, here's the opportunity to enter that if you haven't preloaded it in from a SMS, FarmWorks, or any of those solutions. AFS Connect, what have it be. It's going to ask us about overlap control as well as boundary control. Overlap control meaning that we have to have 99%. So if our row spacing is 30 inches, we have to have 31 3/4 inches of that area in a already applied section before it shuts off. If it detects a 1/4 inch of overlap, it's going to shut off. 30 inches is an average. Of that 30-inch spacing, where's the seed actually placed? On a 30-inch planter. Seed's actually placed somewhere about 15 inches, right? We got 30 inches wide. We're planting to the left and to the right of the actual seed. So at minimum, I wouldn't say we would do over 50%. But because we're controlling each individual row, I would say that your percent overlap at 99% would be just fine. Boundary-wise, we do the exact opposite. We don't want any application going beyond that boundary. We're going to cut that off short. Product delay, 0.5 seconds. That 0.5 seconds is going to essentially be the point at which the seed drops out of the meter and hits the ground. That's about 0.05 seconds. We don't have to, on a 2000 series, we don't have to calibrate that too much from the time that we say on to the time the seed drops. On a 1200 series planter, that's a little bit different because depending on your type of drive, there's a lot more that has to get moving. Hydraulic flow has to get going. Your meter then has to start moving, go through all the mechanical linkages. Seed then has to rotate and then fall. There's a little bit more of a delay than the meter just moving a 1/4 inch and dropping seed down the tube. So don't have to worry about product delay too much on the 2000 series, but for the 1200 series, that calibration will be a little more critical. Start early and stop late. These values here are not a substitute for product delay. If you are going into overlap or driving out of overlap, into and out of a boundary, and your measurements, your seed placement as you dig, your seed placement is not correct, we need to make sure that this value is correct. So again, primarily for the 1200 users, but this setting here is not a substitute to get that correct. This here is insurance to make sure that all the time you are starting 2 feet early or you are stopping 2 feet late. So section control and everything is going to work, but it's going to automatically command that you plant an additional 2 feet to make sure that you have coverage and you didn't shut off early. If I don't have my product delay set, then my product delay may start now. It may take 0.05 seconds for that seed to drop, but the faster that I travel or the slower that I travel, my product delay will accommodate that because it's in seconds. My start early and stop late will just tell the command to start early or stop later based on a linear interval. So if my calibration is off and I really need it to turn on quicker, so I do more start early. I do all my tests at 4 miles an hour. In season, when I get comfortable and I start to run that average of 6, that original distance that I set at 4 miles an hour is not going to be the same. Product delay is going to be in seconds. It's going to accommodate for that time interval. It'll accommodate for my speed. After that's done, daily operation is all we have left. So again, this is what we need to do at the start of season. Make sure we have green checks across the board. If we have all green checks on everything, that means our system is set up and ready for operation. At that point in time, I can hit the daily setup, and it's going to basically walk me through what I need to do on a regular basis when I go from field to field, when I change crop to crop. What settings do I need to look into, and make sure that I have correct before I start recording information. So if I need to change planter configuration or crop types, run the setup wizards one more time. So if I change from corn to beans, if I change that crop type, I'll do a full setup. But if I'm changing varieties of corn, or if I'm changing fields, those types of things, I can go to the daily setup, make sure that I'm my operator, I have the right crop type. So if I do beans, I can change my work condition, match beans. Grower farm field is correct. Operation instance and my task is created. My work condition matches, and the products that I have assigned to each of those layers are correct. So again, if I have a different product that I'm planting in a different field, I can change that product. I can change to a different type of corn. If I have any prescriptions, yes or no, I can load those, or I can leave them blank. And then here it's going to take me to my planter startup. So we'll go ahead and we'll jump to the run screens. We'll talk a little bit about what we can view here. From a start perspective, on the 1200 series planter, we still have this planter system start. It's going to get your bulk fill going. It's going to get your vacuum going. On the 2000 series, that's going to start a few additional components. We talked about the alternator. We talked about the air compressor, wing downforce and delta downforce. All of those options, all of those features will start, liquid included, when I hit my planter system start function. So instead of going to each of these and hitting on, I can actually just hit planter system start. I can hold that down for about 3 seconds, and it's going to turn all systems on. It's going to prime my meter, and I'm going to be ready for operation at that point in time. If I drop the planter in the ground and I see over 1 mile an hour on my speedometer, I'm going to start to plant. Now, I don't have a whole lot on, so I'm probably going to get some warnings, but again, vacuum, bulk fill, liquid, all systems are going to start at the default that I set for that work condition. Couple things we need to verify. Again, hydraulics need to be on, and they need to be set before I hit this planter system start function. If I hit planter system start and I don't have my vacuum, I don't have my downforce, I don't have my alternator, if I don't have any of that on, the rest of the system's not going to fire up. There is a feedback in the system. It's going to tell me if, valve commands a rate of, hey, I need to see 18 inches of water on the vacuum sensor. So when that valve starts up, if there's not flow ready on the planter and it doesn't see that 18 inches of vacuum, it's going to basically shut itself down and say, hey, something's wrong. I need to make sure that all my hydraulics are on before I hit my planter system start. A nice addition that we have when it comes to the 2000 series planters, we have what we call jump start control. So on the old planters, on the 1200s, whether it was a 1200 flat or a 1205, if you backed into a corner and you sat down and you had a hydraulic drive of some sort, we have to see speed before we start planting, before we turn those drives. We have to see over 1 mile an hour. So if you accelerate slow and then you encounter all of the system delays that are in there, you can come up with a decent gap by the time you put the planter down to the first seed that actually came out of the ground. On the 2000 series, we have the ability to do this jump start control, and that's going to allow us to basically come to the point at which we need to plant seed. If we back up to a tree line, a fence row, whatever it is, we can back up, roll forward just a smidge, a couple inches, set the planter in the ground so that way we don't plug our seed tubes. We can hold this jump start control, and it's going to start a countdown. 3, 2, 1. At that point in time, the system is going to ignore speed, and it's going to plant at a default rate. default from factory set at 3 miles an hour. We can change it if we need to. But that's going to allow us to, at the time at which our countdown starts, we can let the clutch out, we can take off. Seed's gonna drop right here, right now. It's gonna ignore systems for about 3 seconds. And then if speed is there, planter's in work, everything else, then after all those checks go through, we'll continue to plant. If for some reason we hit the button and we realize we backed up a little too far, maybe hit the fence row, and we're tangled up in our marker, whatever it is, it'll only plant for a couple of seconds, it'll stop, shut the system down, and then we can address whatever we need to address and do it again. So the jump start control is a really nice button, especially if we need to get into the corner and we can't back up and drive into our application. For the marker control, you can hit left, hit right. We do have an automatic section for the markers, so as you lift up and the frame comes to full raise or limited raise at the end of the row, it's going to trigger the other marker to work. You can alternate back and forth. If that sequence is off, you can hit your arrow. If you're going through the field and you need to move your marker, not all the way up, but avoid the telephone pole, tree, whatever it is, you can hit avoid, pull that marker, and it's just going to pivot up at a 90 degree. It's not going to fold the entire marker in. The views that I have on my run screens, I hopefully set everything up so you guys can see systems. I'll give you a decent idea of if vacuum control is on, here's what you're going to command. Need to raise, need to lower, whatever it may be. You'll show the rate that's then actually sensed in the system. Same thing for the bulk fill, same thing for the liquid. Seed control over here in the left-hand area, we'll be able to watch the seed. If we need to increase, again, our product, I set the minimum as 24, I set the maximum is 29. I'm not going to go in or out of that range. So I can manually command that. Seed graph, I have a blown up seed graph, I believe, on run 3. If you have the ability to look at advanced seed information, it's an unlock that will allow us a bigger view inside of the sensors themselves. So again, we can look between the row unit, single row module, the SRM, that little controller, and the seed sensor. We can go through and determine what our singulation is, if we have any skips, if we have any multiples, what our seed release index is. So a seed release index is how accurately are we releasing the seed off the meter. That could affect your spacing. That'll also affect how good of a ride that row unit has through the ground. So we have some really good troubleshooting information here if we choose to look into the downforce a little bit more for the hydraulic downforce. We're going to have the ability to control and actually look at the pressure that we're going to put on the gauge wheel itself. So the 50 pounds that we have set from the light setting, we can change by the 3 predefined buttons. We can hit custom and change it to what you need. The goal of downforce is to make sure that our downforce ground contact is 100%. Now I understand perfect conditions will be able to achieve that. It won't always be perfect. We want 98, 99, 100%. We want to make sure that each individual row is planting to the depth that we have it. We want pressure on those gauge wheels. Downforce margin is going to give us an idea of how much extra we have. So if we are running no-till conditions, we are running higher speeds, we might want to run a heavy. So you have no-till, you're running 6-7 miles an hour, keep an eye on that ground contact. If that downforce margin gets very small, that means we have a lot of pressures pushing up against. It's hard for those disc openers to stay at depth. we want to run a little higher. The target that we want to make sure that we achieve is that we put enough, but not too much. So we want enough ground contact to be 100%, but we want our margin to be as small as possible and still obtain the ground contact that we're after. So if I want to target at 50 pounds on the row unit itself, the row unit weighs 250. Okay? The system is going to regulate, and it's going to manage the mass that's already on the row, and it's going to look at how much force it needs to apply to get the row unit cut through the soil to the depth that we're after. So if the row unit weighs 250 pounds, I want 50 pounds to be on the ground. If it takes 150 pounds to get the row unit to the depth that we need, are we actually applying any downforce at all? We're actually lifting 100 pounds of that residual, and we're keeping 100 pounds off the ground. You're in a sandy soil, it's nice, it's smooth, well worked, you got a good seed bed, you may not need that weight all the time. You get into the no-till conditions, you get into the faster speeds, that's when you're going to have more friction, that's when we're going to need that extra mass. So if it's downforce, we have the ability to get a little deeper into it. If we have the pneumatic airbags, again on the 2000 series planter, we have the opportunity to watch margin per section. We'll get a good average, and we'll make sure that that ground contact is what we're after, and that doesn't suffer as we change field conditions or go change operations. Now again, your wing downforce control ties into this overall downforce. If I add wing downforce control to a run screen, here on run 5, I got my cleaners set. If I do wing downforce control and I hit info, this is going to give me basically a setup guide as to how much downforce am I running, how much wing downforce do I need to apply to kind of correlate those forces together, so I don't start picking that wing up out of the ground or raising that wing up away from the planter. So you turn that wing downforce on, turn the delta force on, and those two systems will work together to make sure that that row unit stays at the depth you need it. Make sure we're planting to moisture. At that point in time, that pretty well should be a set. Generally, run 2 is going to be your grower farms fields. Again, if you have questions on setup, the wizards that we have will walk you through. Again, you'll start back where you left off. So if you left off in a screen, you didn't complete something, it'll take you back there. But your operational, your full season setups are going to be basically at crop type change. Your daily operations will be within that same crop, field to field, prescription to prescription, crop type to crop type, whatever you change as you progress through season. This is the setup that we will follow to make sure all of those values and all of those settings are predetermined. So with that, I wish everybody a good start to season. Hopefully this gets you in the mindset to start walking through the planter, get things hooked up and kind of prepped. So once it's time to actually get in the field, you guys are ready to go.
Real quickly, just want to thank Eli for putting on this presentation today. We really appreciate it. Done a fine job with it. We appreciate all the support from Case IH and everything that we do. Also, you can't see them standing around the room here, but we've got a group of our technicians from the different locations are here joining in on this. Those of you that set in, appreciate Paul and Scott setting in. but we have other guys around the room here, the entire support group from the different locations. I want to thank Networks Plus for putting this on the YouTube for us. We had a few glitches along the way, and the great part with them is they think fast on their feet and they figured things out. So we do appreciate that because glitches happen. The entire Bruna organization, though, thanks you for being customers. If with those glitches that we had at the beginning, if you have a neighbor or friend that had a little trouble getting on, please just have them call in, and the local store will have the link again, and we'll put up by tomorrow. Maybe we can have a location where they can click on something and rewatch it sometime in the next few days. So again, thank you for being customers. We appreciate your support, and again, thank you, Eli, for that fine presentation.
Yeah. Thanks, Martin.
Have a nice day.